Okay. Okay, so today we're gonna see databases. Okay, I don't think it's gonna be something quite new for you guys because we've been speaking about this. Um, Means we spoke about this several times. I always mention this. Okay, so Amazon Relational Database RDS is gonna be part one. Amazon Dynamo DB is gonna be part two. Amazon Redshift is going to be part three, and Amazon Aurora is going to be part four. Part four. Okay, discuss the key concepts related to database, including provide an overview of different database services in the cloud, highlight the difference between unmanaged and managed database solutions, understand the differences between structured query language, okay, and NoSQL databases, and review the availability differences of alternative database solutions. Okay, RDS. This is the symbol, the icon of RDS. If you take a look at the Aurora icon, it's the same thing. I don't know why they decide to have Aurora icon the same as RDS. I have no idea why. Maybe because Aurora is proprietary of Amazon. Probably is the only one that belongs to Amazon. I have no idea. I have no idea how they came up with these icons that they use for every single um, services. Some make sense, and others don't make sense to me. But they have a reason. There's a reason behind it. Okay. Okay, so we have unmanaged managed services. This is something that you already know. You know, something that is unmanaged. You have to take care of everything, right? Scaling, making for fault tolerant and available, everything that have to be done by you, and manage everything is done by AWS. It's done for you. Okay. There are some services that are fully managed. There are some services that are managed. Okay. When it's fully managed, it's even more managed than AWS, completely managed by AWS. When it says manage only, there are some things that you have to do, but most of the things that need to be done are done by AWS. Okay. So challenges of relational databases, I don't know if you guys, have you ever worked with any database system? Any database management system? No? Never?
SQL,
Hmm. Sorry?
SQL.
My Gabriel is that Gabriel said my SQL. Who's the other person that spoke?
Oh, that was Gene.
Jean. So you use SQL. Okay.
It was just an introduction.
Okay. Okay. Anyone else? No one else?
I have used Excel as a database.
Okay. Yes.
SQL, yeah.
Yes.
There are different
I'm sorry. Can you
there are
repeat that,
different
please?
there are different levels that you could use
Yeah.
for the database.
Hmm. Okay. So server maintenance. One moment. I'm using a mouse for my Mac computer, and it's so sensitive. So sensitive. Okay, software installation and patches. Okay, all of this have to be done by you guys. That's the challenge. Okay, that's the challenge. You have to have backups in place. You have to make it highly available. You have to create all of these things here. You have to create the tables, the rows, the columns. You have to um, Of course, if you have it on AWS, you have to do it too. But I mean, I'm talking about the things that you have to do because you have to do them, and the things that you are not. I mean, you can choose not to do things like this one, right? By having your own relational database and not having it on AWS, right? So all the things that you have to work on, like you have to patch it, you have to install software. Is there any update? You have to update your database. You have to have backups in place. You have some limits on scalability. So to make a database scalable, it's kind of hard. You have to, create some tables manually. You have to delete tables manually. It's kind of painful. Okay, you have some issues with security. You may not have issues with security, right? But you have to work more on security because it's not managed by anyone else. It's managed by you. So you have to make sure that there's no, SQL injection attacks, things like that. People that try to put some queries in your database and get the information. You have to be careful with the variables that you use. For example, if you use a programming language, um, and you make queries to the database, you have to be careful and use parameters instead the actual column names and values, all that in your queries. You have to be very careful with that. The operating system that is working, you have to patch it, you have to install it, just in case you want to do any updates or anything. So these are the challenges that you will come across if have your own database and all that. Right? Now, Amazon RDS is a managed service that sets up and operates a relational database in the cloud. This guy is not fully managed because you have to choose the engine, right? You have to choose the engine. You have to do some configuration there. So it's not fully managed. It's not like DynamoDB that is completely managed. In DynamoDB, of course, you have to create your table, right? Amazon is not going to create the table for you. It's your data, right? You're the one that knows what you're going to have in your table. So you have to do that. But for this guy, you have to do some configuration and you have to choose your database engine. With DynamoDB, it's only DynamoDB. There's no other engine, right? You have to run your queries. You have to do all that. So you have the users here, and then you have the application servers, right? You also have the guys, the EC2 instances that you have in another layer, right? And then in the other layer of instances, right? These guys I guess they will probably be in a private subnet, both of them, right? The application servers and the RDS. So you have to go here, and this is in the cloud, just in case this is out of the cloud, but this is another thing for a hybrid, architecture. So you have databases on premises. You have to manage all this, right? Because it's not in the cloud. It's not in the cloud. This has to be done by you, right? Optimize the app, scaling, make it available, the backups, database software patches, database software installs, all patches, OS patches, installation, server maintenance, rack and stack, power, all these guys, this is heating, ventilation, AC, all that, and the network, all that. So you have to work on all this, right? If it is on premises. Now, if it is on EC2, because like I said before, you may have an RDS instance on an EC2. Okay, it's like having your computer. It's a server, right? You may have a database installed in your computer. Same thing in the cloud. You can have your EC2 instance, right? And you can have an RDS on top of that EC2 instance, right? So in that case, you're going to manage some things, and AWS is going to manage some things for you. As you can see here in the graphic, in this chart here. So you have to do all this, but from this place here, you know, this is going to be by AWS. You don't have to do any of this, right? But this is not highly recommended because you have to still work a lot, okay? What is more recommended is to have everything in the cloud so you work less, right? So you have to optimize the app, right? You have to optimize it. You're the one that's working on the app. You're gonna make it better. You're gonna make it. This is by improving the relationship between the tables, have better queries. Have create the foreign key, the primary key. Make your database, your tables more optimized. That's what you have to do, right? The rest is done by AWS. So if you take a look at these three scenarios here, I don't think it would take you more than 2 seconds to decipher this one, right? Because it's less work for you, much less work for you. Okay, and I'm sure you're gonna be saving more money than if you're here, right? So cost is not a problem here. Availability is not a problem. Scalability is not a problem. The only thing that you have to do is take care of your database. Okay, when it comes to the tables, all that, like I said before. Okay, so you can take a look at this later and see the differences, but it's obvious that this one is the most optimal for this three. Yes, go ahead.
Can I ask a quick one? I assume you're referring to third scenario in which you will tell us in a second, but RDS I assume may take care about high availability and scaling on its own, because on the second scenario in the cloud I do have as well the possibility of having scaling and high availability if I use ELB or whatever other service, right? So second and
here. Right?
Yeah.
Here. Remember, you are in an EC2.
Yeah. I'm on an EC2, but I can have as well high availability in AWS.
Yeah, but it doesn't mean that it's not available. It means that you have to work
manage it.
You have to manage it. You have to create auto scaling.
I have to get the services. What you're about to say is that in the third scenario, scaling and high availability comes within Aurora, for instance, right?
Which one? This one?
Yeah, in that one.
Yeah.
It comes within RDS or Aurora.
Yes.
AWS does it.
Okay. It does it for you. It's managed by them. Okay. In this case, you have to do it on your own on premises.
Yeah, that's true.
Here, it's there. But for this, for example, you have to use Systems Manager, so you can install all the patches. All these guys. You have to have this EC2 in different availability zones, so you can make it more highly available. You have to create scaling. You have to have snapshots of the database, all that. Here, you don't have to do any of that. Okay.
Professor, cost-wise, what's the difference between, say, the database in your EC2 or the Amazon RDS?
It depends on the instance type.
Okay.
The instance type, you have to see how big your instance type it is.
Because I'm wondering why would somebody want to do the database in the EC2 if you could have it, if AWS can do it for you in the Amazon?
Simply control.
Just control.
Control. Well, okay. They may save more money if it come here. It depends. It all depends, right? This may be cost efficient, but if you select,
you don't have the control.
That's right. If you select a very strong database, like a really high family instance or instance family, it may be more cost efficient, less cost efficient than this one. Okay, and Aurora, for sure, is going to be more expensive than this one. Aurora is a high-end database. Okay, and when we get there, we're going to see why. Okay, So you manage the application optimization, and then AWS manages this, right? That's for the third scenario right here, right? All of these guys, so this, it might be in your exam, okay? They may ask you, if the company has an RDS database system, what is the responsibility of the company? And they may give you several options, so you have to be careful, and they would tell you select two or choose two. So in this case, they will not tell you select two because it's only one, right? But they will tell you what is AWS's responsibility. Choose two, okay? So be careful with this. Like we said on the first day of class, the share responsibility model. The share responsibility model is super important. Okay. What is AWS's responsibility? What is the customer's responsibility? You have to know that for sure. Okay. So RDS instances, you have here a DB instance class, right? The instance class is what we choose, like X large or things like that. That's the instance class, okay? You may need some CPU, some memory, and network performance, right? Now with DB instance storage, we can have magnetic, general purpose, SSD, and provision IOPS. So we can use the same thing as the EBS, remember? EBS. RDS DB masters instance right here, right? Just to tell you what you have in your RDS instance, the things that you have, right? This and this. Now, these are the six engines that RDS supports. Don't forget this. This is very, very important, right? Very, very important. The only one that belongs to Amazon is Amazon Aurora. The other ones are third-party database systems, right? MySQL, Aurora, SQL Server, PostgreSQL. This is super popular. I have used it so many times, right? And MariaDB, Oracle. Those are the six engines that RDS has.
You don't need to have an EC2 instance tied to an RDS to access this database, right?
What do you mean?
Could you have a instead of EC2 instance, you can have anything connected to this database, right? Even third party, front end, applications.
Yes,
right?
Yes.
Oh, okay.
EC2,
I just want.
EC2
Sorry, I just want to confirm with you that that's the case.
EC2 is just an option.
An option, okay.
Yeah, or it's just an option. Let me see here. All right, it's just in case you want to have a server in the cloud. You know, you may have a server on premise. You know, let me see here if I come to this RDS thing. Okay. So we have this guy here. I can create a database. I don't have any databases right now. Right. So I can create a database here. I can create a database. I can choose here any of the six. I don't want to create Amazon Aurora because that's painful. I don't want to create a PostgreSQL, right? And I'm going to choose version 12, which is the latest. Okay. I'm going to choose the free tier because if I choose production, I'm going to be charged, right? And production is the one that has multi-AZ, you see here.
Yeah.
So you can have different availability zones there. But I'm going to choose the free tier that doesn't come with any multi-AZ features. It's graded out, doesn't have any choice there. So this one is only for, you know, for testing and for playing with the database, all that. So I'm going to give you here my first database. Let me say my first RDS. So the master's user is gonna be Postgres, right? And this one's gonna be password. Just for me to remember. Okay. Dbs instance, burstable is burstable. This is, you know, the T2 micro. That's the one that comes with the thing, with the free tier. I'm gonna choose the storage type. I can use general purpose or provision IOPS. I can choose here how many GB bytes I'm gonna have. Enable storage auto scaling, you know, auto scaling, it auto scales. Maximum storage threshold, 1000. Charges will apply when your database auto scales to the specific threshold. Okay. Connectivity, it's gonna be inside my whatever. I can choose it inside my custom VPC, the one that I created before. And after database is created, you cannot change the VPC selection. So you have to read all these things here, all these warnings that they give you. Additional configuration here, subnet, I can choose a subnet group, but I have to create a subnet group. You can do that too. I want to make it public, right? I want people to be able to access my database, or people, or not people, applications, right? Choose an existing security groups. I can choose a security group here. Create a new one. I'm here. This is the port. Oh my God. Okay, 1 moment. Wait. I think it's 32. That's the port for Postgres. Okay. No preference. I can put it in my availability zone 1A. Security group, I can give it a name. Probably my RDS security group. Okay. I'm gonna put it in lowercase. RDS security group. Okay. So password authentication, things like that, and the cost, there's no cost to this. Okay, it's gonna be free. You have 750 hours as Amazon RDS in a single AZ with this family, this class.
Can you go back up to database authentication right there? Password and password.
Okay, so
so
you
can do it with a certificate, or you can do it with an EM, or just password.
Password. Okay, authenticate using database password.
Is that the only one that you can choose, or can you choose either one of those two with the free tier?
You can use these three.
Oh, okay.
Okay, but I'm gonna choose that one. So I create the database. It takes a while. It takes a while to create this database, you know. Well, actually, let me tell you something. This is not the table, right? This is only the platform. This is only the platform, right? Now I can use, there's a guide that I use for this, right? So let me make this a little small, right? And let me bring another guy. That is the one that I use for databases, right? It's a third-party software where I can create my own database, or I can use Postgres engine, right? But I like to use this guy that sometimes becomes a little painful to connect to, but you know, I have learned how to use it, so I love it. Okay, let me show it to you.
That's for your schema.
So this guy here. Okay. So I can have this guy. It's dbeaver. dbeaver. See here? dbeaver.
Mm-hmm.
The icon is a beaver. Is a beaver. Okay. So when this is created, I can come here and connect it. You know, I have several engines that I can connect to here. a lot of them, you know, a lot of them. So I can use this guy is the one that I'm trying to connect. So what I have to put here is the local host. The local host is going to be the endpoint that the database gives me. The database is going to give me a URL. That's the URL that I'm going to use here, right? And then the database is Postgres, like I did before. Username is Postgres, and then the password. Did I choose a password?
Password, just password.
Oh, password, yes.
Just password.
So I can put here a password, and whenever this is ready, okay, we can. It's still in the status of creating. It takes some time, right? So we're gonna come back later, and we're gonna try to connect this guy to this, and then I can create my first table here, right? So we see this RDS like a bridge. It's like a bridge that connects this guy or Postgres. I can use Postgres, right? I can use my own Postgres database. It connects this with any application that accesses this database. And also it connects me and RDS, okay? But RDS is not a table. RDS is not a database per se. It's just a database in the cloud that you can use to create tables, right? It gives you the platform. It gives you the platform to, on top of that platform, put a database. Do you understand what I mean?
Yes.
You don't create the database
Yes.
here. You don't create a database here. You don't create your tables, your relational database here. You just have it like a platform that AWS gives you where you can host your database. You understand?
This
And then
is like a database server, basically. That's
what it is.
Mhm.
That's what it is. It's a database server. It's a server. RDS is a server pool service. It's a server. So we're gonna visit this later. It's still creating. It takes some time. I don't know why it takes some time. Right now, it's the configuring enhanced monitoring. You see, it has enhanced monitoring. Still free. Okay. So we can continue now. So we have here RDS in a virtual private cloud. We saw this before, right? It's very similar to what we saw before. So we have a server there in the public subnet, right? And we have another RDS and another server, an RDS here in the private subnet. So we have the internet gateway, and then we have the user. This is very familiar to us, okay? Very familiar. Now, how can you make your database highly available? Okay, it's by enabling multi-AZ. Remember what we saw before? In the production database, RDS, you can enable multi-AZ, and then you're gonna have a standby database here in the other availability zone, just waiting there. If something happens, it will fail over to this one, right? And every single replication is synchronous. It means that it's gonna be instantly right here, right? It doesn't take any time, any delay. There's no delay, right? Or actually, it takes time. You know, if it is 1 second, it's time. 2 seconds is time. What I'm trying to say is that the replication is gonna be without a very big delay. It's gonna be right there as soon as you do the replication.
Can you manage that replication time frame when you do this configuration, or is it set?
Well, first in my RDS right now, I cannot do anything because I don't have multi-AZ. I will have to create the production one, but as far as I remember, the last time that I checked, you don't have to put any time. You don't manage that time. I create several databases in production, and you never establish the time. You never set that time.
Okay.
It's just a standard time. It's synchronous. It's gonna be almost instantaneous. Okay. The one that is not synchronous, is asynchronous, is read replicas, right? If you create a read replica, that's going to be asynchronous. There's going to be some delay in the replication. Okay. So you're going to be accessing this, probably writing information here. Remember, if someone places an order here, an order. Let's say that this is a store, right? A retail store online. This is Macy's, for example, online. You place an order, then the order is going to be stored here, right? And the order is going to be stored here too. Okay, just in case something happened, like in this scenario, you know, this database fails, right? And let's say that one of the users wants to access his order by order ID, right? So instead of coming here, because the application it's all coordinated, they know that this is not working right now. So what it's gonna do is get the order from here, right? Maybe this one is maybe this database is going is undergoing some maintenance, right? And they just fell over to this one, and this one is the one working in the meantime. Now, I would recommend having another standby, you know, because if they both fail, you have a problem, right? This should be enough, right? This should be enough, but you never know. It's very unlikely that two availability zones go down at the same time. I mean, that's very unlikely, but you never know, because they are built in a way, they are isolated from each other, and there's a distance here, like 50 miles, you know, it's like 50 miles. If there's an earthquake here, probably there's nothing here, right? It's 50 miles between one and the other. Let's see if it is created already.
Professor, sorry, what was the M and the S? What did that stand for?
Which one?
The M and the S.
Oh, this is master, and this is standby.
And standby, thanks.
Okay. This one is not doing anything as long as this one. I mean, when this is working properly, this is not doing anything.
It's just standby.
It's just been getting replicated information, and that's it.
Yeah.
Just in case for failover, if something goes wrong. Okay? If it is a read replica, yes, it's gonna be using both. Okay, both. So for Amazon RDS read replicas, like we said before, right? It's asynchronous. Okay, promote to master if needed. Okay, just in case you want to make this a master. Don't forget that the difference between, guys, I want to ask you, what's the difference between a master and a read replica? Do you have an idea? Can you tell me if you have an idea of this?
Master is like the gold image, and replica it's a copy of it.
Okay, but there's another difference. A copy of this, so is this one. Right?
So master is where everything's created.
Is it read only?
Could it be the replica?
Correct. This is only read. Okay.
That's only what?
Read and write. This is read only.
Yeah.
It's a read. It's a read replica.
Okay.
So here, what you do is only read. You don't copy anything. You don't write anything here. Master, you write and read. Now, if you want this to write and read, then you have to promote it to a master. Okay? You have to promote it to a master. This is not very important. This is not used for failover. This is not for failover. Failover is this one, the standby. This one is for performance. Improve performance in your database, right? This is for improving what? Availability. And this one is for improving performance. Very important. Don't forget that. Okay? Read heavy database workloads. Just in case this database is getting a lot of traffic. It's a lot of work. You want to offload that amount of work, you can create a read replica, and then it's going to be ready for both, right? Ready for both. from both, and then it's gonna be, you know, your application is gonna be better performing. Okay. Good. So let me see. It's available right now, right? So if I click on the database, I can come here, and you see the endpoint here. That's the endpoint. What I have to do, this is the link that connects my Dbs with my database. Okay, is it public? Yes. If it says no, forget about it. You will not be able to connect. So localhost, I'm gonna paste this here, and let's see if it connects. It connected. It's connected already. Now I can come here. For example, let me see, what is the editor? I can see here, create table, and then the table is going to be named users, right? This is SQL, okay? A little bit of SQL for you to understand a little bit. Table, say users, say user ID, serial, and then primary key. Okay, that's the primary key of your database, of that table. You can say first name. I can say this is text and none. That's actually not null. Okay. And then I come here, says last name, text, not null. Okay. And this is H. And then H, no, H is a keyword. I cannot use it. Let's say user H. And that says this is going to be an int and it's not null. Okay. Not null. So I have to do is run this thing here. Boom, it's created. The table is created for you. So if you click here, it says schemas, and then come here, what it says public, and that's what it said table. Why? Oh, let me refresh this. I think I have to refresh it. Where's the refresh button here? There you go. There's the table, right? These are the columns, all that. Now what I have to do is just give it information and use insert into users. And then I can say,
Excuse me, I'm sorry.
yeah, first name. I put here the columns, last name, and then user H. And then I can say values. And I can say my first name is Dunieski. Last name is Otano. And the H, as it is an int, is 43. I'm 44, not 43. Okay. So now I can run it. I'm supposed to have a semicolon at the end, but I don't think that's necessary with this guy. So now I can run this and boom, the table is created for me. And then I can say, select everything from users. So give me everything from users. And now if I run this guy, I have all the information here. This is my first table that I have created here. Okay. So all of this is hosted here in this server. Okay. So I can have my database here. Now I can connect to this from my EC2 instance, right? And pull the information from here. Okay. Or I can have my own server or whatever and pull the information from here. But it's all being hosted here in Rds. Okay. So this is my first table. I can create as many tables as I want, and I have a relationship between them, right? I can have another table, for example, audit table, create table orders. Okay, you can have a table for orders, and you can say whatever you want. Another table for orders in case if it is a store or any website that sells things, whatever. I don't know. So this is what happens. All right. The database even has a certificate here. You see here? So it's all secure, right? And it will be valid until August 22nd, 2024. All right. So, but this is managed by AWS. You don't need to worry about that. That's managed by AWS. But as you can see, it's a secure database. All right. So this is high level, how you can create a table, how you can connect RDS to this, right?
Professor, quick question.
Go ahead.
On the time limit, is that because it's a free, because it's a free, it's on the free one?
Which one?
The August 22nd, 2024.
No, because things have an expiration date. So
Okay, but
it has like, it's valid for 4 years.
Okay.
Right. After that, AWS will renew it themselves.
Okay.
You don't have to worry about that.
Okay.
But after 1 year, when your free tier account it's over,
Yes.
You might need. I mean, if you have a big company, you might need to change the type of RDS.
So if you want to maintain your information, you have to get a paid account.
No, yours is gonna be turned into a paid account after 12
Okay.
months. You don't have to do it.
Okay.
After 12 months, you're gonna be charged for this.
So you're not going to lose your stuff, basically.
No.
Okay.
Remember, when you created the account, you have to put a credit card.
No, credit card yeah.
So forget about the rest. AWS will take care of that.
Okay.
But they charge you when you use it. So.
Well, right now it's being used. It's running.
No. But if you're not using the services.
No.
Yeah, they don't charge you for it.
No, right now you can use it 750 hours, right? But if you use it 1 second after 12 months, you're gonna be charged. If you don't use it, you're not charged for anything.
Mm-hmm.
Remember, AWS is pay for what you use, right?
Pay for what you use. Yeah.
You don't use it, you don't pay for anything, and pay as you go as well. Okay.
This is very useful. Thank you so much.
What part specifically?
What you just did, it's amazingly useful to me.
Thank you, appreciate it. So this is I created a full stack application using this system, exactly that system, right? So this is the way it is. Okay, you can use other. In this case, I'm using Postgres, but if you create another one, you can use these guys here. So you have several databases here in this using Dbeaver. Dbeaver is super useful. I love it. I love it. It's super popular too. Right?
So in the case of DynamoDB, you will not do this, obviously. So
No.
DynamoDB has its own way of creating your schema.
Correct. By the way, DynamoDB is schemaless. It doesn't have a schema.
Schemaless. Oh.
Yeah, DynamoDB is an unstructured database. It's not table primary key, foreign key. No. Dynamo is completely different, and it's NoSQL. You don't use this for DynamoDB.
Are you going to give us a demo how it works?
Yeah, I can give you a demo how to create a table.
Okay, perfect.
But then for the other things, you have to create Lambda functions. You have to use a third-party thing like GraphQL, for example, and that's another language. That's another thing that it's a class on itself, on its own. I had to learn GraphQL when I was in the College Board, and it's a good thing because it uses JSON, and I know JSON, but it's painful. It can be painful too. Right? Okay, when we get to DynamoDB today, I'm gonna show you how to create that. Okay, so promo to Esther. Okay, we saw this already. Use cases. When do we use RDS? In web and mobile applications, high throughput, massive storage, scalability, high availability. Okay, so we can use RDS for this. For e-commerce applications, low cost database, data security, fully managed solutions. Right? Now, for big companies, big companies that have a lot of workloads, big, massive company data, they will go for DynamoDB more than RDS. DynamoDB is more powerful, and if you want to be highly available, highly scalable, more than RDS, DynamoDB is the guy. All right. So mobile.
Sorry, say that again. I was making some notes. I apologize.
Yeah,
Can
if you
say
want
that
to
again?
go more heavy duty, and if it is a high-end company that has millions and millions of customers and tons of data and big data and all that, you might probably want to go with DynamoDB instead of RDS. Okay.
And the
And
reason
all
for that
depends.
is because it's what are the main reasons?
Because DynamoDB is super, super, super highly available and super, super scalable, more than RDS, and it's fully managed, fully managed. RDS, you have to do some configuration, right? And also, if you want to go with a NoSQL solution.
Okay, so it's the NoSQL solution.
Yeah, this is SQL. Okay. Mobile and online games, rapidly grow capacity, automatic scaling, and database monitoring. RDS is super powerful, but DynamoDB is more powerful than RDS. Okay, so when to use Amazon RDS, when not to use it. We use RDS when your application requires complex transactions or complex queries. Okay, so this is not complex, right? Right?
No.
But if you want to go with transaction, then you have to do begin, and then at the end you have to do commit, and then you have to create a transaction here, a big one, where you create a table, put information. You can put all this here inside this guy here, And the good thing about transactions is that they are ACID. Okay, they're ACID. They're atomic, consistent, isolated, and durable. That's the good thing about transactions. This is an acronym that you don't have to remember, but just for your information, that every transaction is atomic, consistent, isolated, and durable. Okay? What is durability? For example, when you transfer money from one account to the other, no, that's not durable. No, it means that what is consistent is the one that you have, as you go from a solid state to a solid state. That's what consistent means. When you transfer money from one account to the other, you want to make sure that the money is in the other account, right? Okay, that's consistent. That's a transaction, right? Durable, it means that it's always going to be there unless you take the money out, right? Atomic is that it happens real quick. I mean, it's atomic, and then isolated means that one process happens on its own. Okay, it's not dependent on the other processes. Okay, so it's taken like that's the only one process taking place. Okay, so that's one of the things of transactions, and all the thing is that it's everything or nothing. Okay, if something fails here, it will roll back. Everything will roll back. It won't even get here. Okay, so it's everything or nothing. So that's the good thing about transactions. Okay. So when you need complex transactions or complex queries, you have RDS. Remember, DynamoDB doesn't have queries. It's NoSQL. Okay, so you have a medium to high, very write rate up to 30K IOPS, 15 reads and 15 writes. Let's use RDS, right? Up to. If it is more than this, then you should go for something else. Okay, RDS is up to. No more than a single worker, node, or shard. Okay. And high durability. You have more than a single worker on shard, then you have something else.
So what's that shard thing?
Remember when we saw shards before? I think it was in this class or the other one.
No.
I confused because I have two classes. Yeah. Sharding is a way to partition your database. you can partition your database in shards, right?
Okay.
So if you have only one shard, this is a guy, right? RDS. You have more than one shard, then you will need something else. Okay. So as you can see, RDS has its own limitations. Okay. It's powerful, but it's had limitations. Now, the other side, this is when we have to use something else. When you have massive reads and writes rates, for example, 150K write per second. Okay, so you need that, you have to go for something else. So it all depends on your business, your capacity, your database strength, I don't know, the traffic you're getting, everything depends. So you have to sit with an architect or someone that knows about it, and we have to analyze your business model, and then see what's going on here. Okay, so sharding due to high data size or throughput demands, right? Single get put requests and queries that a NoSQL database can handle. Okay, so if you have a request that SQL, can handle, then you have to go for DynamoDB. Okay, and then the Relational Database Management System, Dbs Customization. Yes, if you have to make some customization in your system, then you cannot use this because this is very strict. It has a strict schema. It's very strict. It doesn't allow for customization. Then you have to do something else like a schemaless, something like you can do whatever you want. You know what? Which is another one that is a schemaless? MongoDB. In MongoDB, you don't have a schema. I mean, you have a schema, but it's not SQL. It's a different one. It's a different way to do it. Okay, and MongoDB is super popular right now, especially for MERN applications. When I say MERN, okay, MERN, that's MongoDB, Express, React, and Node. Okay, these guys are super popular right now for full stack applications in the backend and front end. This is for the database. This is for the server, to create a server, right? This is for Node. This is a runtime environment for JavaScript. And this is a JavaScript very popular component library. Actually, in my website, the one that I just building, this guy has this guy, React. Okay. It doesn't have the other three because I'm not saving anything in the database, and I'm not using any server in the backend because React itself is a server. Okay, but you can have two servers working at the same time, right? I've done that in the past. And if I want to, for example, if I want to put some reviews here, I want to let some students put reviews here of my job as a professor, then I will have to use a MongoDB table, right? And I might use this too, because I want to save the reviews. If I want the reviews to persist there on a section here, when you click on reviews and then it shows you all the reviews, I have to have a database that saves every single review that is entered, and then it displays it when you want to see it. Okay. So full stack development is beautiful, but it takes some thinking and time. Okay. So Amazon RDS, clock hour billing and database characteristics, clock hour billing, resources incurred charges when running, if it is not running, nothing. So database characteristics, physical capacity of the database, the engine, what kind of engine are you using? Using Postgres, it's gonna be cheaper than Aurora, okay? the size of the database, how big it is, right? Especially the class. We chose T2 micro, right? The memory class, that's the memory class. The size is talking about the how many gigabytes, okay? And the memory class is T2 micro, okay? So those are factors that will influence the cost of the database. Also the DB purchase type. If it is on demand, database instances, compute capacity by the hour. Just like we have EC2 instances that are on demand, we have DB database purchases that are on demand too, right? Depending on, same thing for predictable patterns. If it is reserved, if you think that, it's going to be a predictable pattern for the whole year, so you can go with a one-time upfront fee, very low, okay, for a year, right? Now this one has a one-time fee, okay. It's not like EC2 that you may have a choice of not having any upfront fee. Here you have to have an upfront fee, okay, and it's only one time, and it's low, okay. How low it is depending on how much you're reserving. All right. I think this is one of those times when the upfront fee is based on the purchase you're making. All right. So number of DB instances, how many instances you're creating, provision multiple DB instances to handle peak loads, how many standby do you have, how many replicas do you have. So that's going to count for the cost of your database. One more slide, guys, before we go on the break.
I have a quick question, Professor, about the last point.
Yes.
So let me see, where are we? Okay, provision a multiple database instances to handle peak loads. Okay, so let's say, in terms of what you reserve, it's not enough to handle it turns out to be not, you've underestimated. Like, what would happen in that case?
Well, you reserve for some instances, right? If you need more, you're going to be charged for that.
Okay, so right, okay.
Because so, you may predict that you're going to need 2 for the whole year, but well, maybe you have more. Okay, so you can add more.
So it will just is the word scale? It will just scale.
Yeah.
Pay more.
Yeah, and then you're going to be charged for that.
Yeah.
Okay, so also provision storage, if it is, IOPS, general purpose, there's no charge for backup storage for the active database. There's no charge for that. Up to 100 is telling you for the entire database. There's no charge for that, right? That's free, right? Which is a good thing. So you're going to be charged based on gigabytes per month, right? Backup storage for terminated DB instances, you're going to be charged for that, right? So the difference between this one and this is one for active databases, and this was for terminated ones. When you terminate the database, I'm going to show you later, it's going to give you the choice. It's going to give you the choice to, let me see if I can terminate it here. You see, I can retain an automatic backup, right? If I want to. All right, I'm going to be charged for that. Well, in this case, I'm not going to be charged. It's a free account, right? But you're charged when you terminate an instance, right? I don't want to consume. I don't want to create a final snapshot, okay? I just want to delete it. And there's something here. I want to acknowledge. Delete me. Okay, and then it's in the delete process now. Deleting database instance. Okay, I don't need any of this. Okay, so for running instances, there's no charge. For terminated instances, there is a charge. Okay, gigabyte per month. It will be calculated for you depending on what you have. And if you want additional storage, you want to add some more storage here, then the backup storage, in addition to provisioning storage, is going to be charged. So two things for what you charge: for additional storage and for backups of terminated instances.
If you want the storage backed up.
If you want it, you have the choice. As you saw here, I have the choice. Okay. Okay, guys, let's have a 10 minutes break. Okay, so I see you back at 10:44. Hey guys, we're back.
Okay.
Okay, before we continue, I want to tell you guys, if any one of you has not responded to the form that I sent yesterday, please do whenever possible, so I can send you the resources that everybody's getting for that. And we might give you some more resources. I'm just waiting on Miami-Dade College for other access. So, you know, you're going to be really prepared for that exam. All right. So if you haven't confirmed, please do it. I will appreciate that. All right, let's continue. So also you're going to be charged for the number of requests of input and output requests made to the database. You know, whenever you fetch information from the database, you're going to be charged for that. Deployment type, storage, and input-output I/O charges vary depending on single availability zone. Of course, the more availability zones you have, the more you're going to be charged. Okay. So high availability costs money, right? Data transfer, no charge for inbound data transfers. Tier charges for outbound data transfer. So you're going to be charged for outbound and no charge for inbound. So that's something that you already know. Right. Nothing new. So review what we saw: set up, operate, and scale relational databases in the cloud. Features include managed services, difference between managed and unmanaged. Accessible via the console. You can access the console like I did. The CLI, you can create an RDS using the CLI, right? Or simply an API call, like for example, using CloudFormation or a Lambda function, all that. Scalable compute and storage, automated redundancy and backup available. Okay, when you select multi-AZ, you know that's automated after that. And supported database engines. What are the six engines that RDS supports? Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and Microsoft SQL Server. Guys, everything is important in this PowerPoint. So take some time to watch this video again, or simply go over the PowerPoint again. And if you have any questions, guys, you can ask me on the chat, and I will get back to you as soon as I can. Okay. The fastest way to get to me is it's through Slack, not through email. Slack is faster than anything else. Right? Or you can post a comment on Google Classroom too. So Dynamodb, it's a whole different concept. It's the let's say it's the opposite of RDS. Okay. Just the fact that it's a NoSQL database, it makes it completely different. Right. So what is Amazon DynamoDB? It's a NoSQL database table. Okay, it's a single table, right? It's a single table. Even though you can have global tables, that's a feature that DynamoDB has. It's a global table. That's what makes DynamoDB even more powerful than RDS. Okay, you can have tables in the entire world. Right? It's virtually unlimited storage. Okay, virtually unlimited. Items may have differing attributes. Right, low latency queries. It's super fast. And scalable read and write throughput. Okay. When you create a DynamoDB table, you have to select the capacity of the read and the capacity of the write. Okay, that's something that you have to do because you have something they call eventual consistency and also strong consistencies. That's something else that's for the developer exam, but at least you should have an idea that they have some things that you have to configure, but DynamoDB is fully managed. So you don't have to manage any scalability or any availability. That's all done for you. Okay. The components of the table is composed by items and by attributes, right? And they are the core DynamoDB components: tables, items, and attributes, right? It doesn't have a schema, so you may have one row that has 4 items or 4 attributes. You may have another row that has 10 attributes. It's super, super, super crazy, but you can get to understand it, and it's going to be super, super effective. Now, in a relational database, we had a primary key, right? And then that primary key is going to be probably connected to another table through a foreign key, because whatever is primary key here in another table is going to be a foreign key. So the relation happens between primary key and foreign key, all that. Now, this is not a relational database. There's no relations between tables, right? But when you create a table, you can create 2 kinds of primary keys, right? In this case, we have only one. It's user ID, right? Here, we have 2 primary keys, okay? We have the partition key and partition and sort key, okay? This is usually for IDs and all that. And this is usually for things that can be sorted. For example, creation date. Or for example, I don't know, a last name, for example, something that can be sorted chronologically or alphabetically, okay? So we have the partitioning here. As data grows, the table partitions by key, right? The query by key to find items efficiently scan. We can have something called scan. You can scan something to find items by any attribute, okay? I'm gonna show you on the table, okay? So you can have a single key. That's for the table, single key, a partition key, and attributes, right? Or you can have a partition key and a sort key, okay? The sort key, usually a date, and here can be an ID, right? All right, let me come here. So I can come here. This is still deleting. It should be deleted already. Okay, should be gone now. I want to make sure it's deleted before I do anything else. It's taking too long. Let me open DynamoDB in the meantime. So I can go here, DynamoDB. So I'm going to create a table here. Okay. So I can name it my DynamoDB first table. Partition key, let's say this ID. Right. I can add a sort key, and I can put here. I'm not gonna do that now. I'm gonna create one without a sort key. Okay. So that's all it is. That's it. You know, that's a single table, right? Single table. RDS still loading. I don't know why it's taking so long. Okay, so the table has been created. That's the table, right? Okay, so I can create an item here, right? I can say create an item, and then the ID, say it is the SQ01. Okay. Then I can add another here, another string, say first name. And you got another attribute here, say last name. And you get another one here. It's a number. It's a H, and then 44. All right. So now I save it, and there you go. There you have the first. So I can enter an interview here. Let's say, yeah, what about that now? So this is my first database, my first item, right? I can have another item. Look how crazy this is. Another item, say Orlando 001, and I can have here, let's say products. I'm gonna say iPhone. And then I can say here, wife name, and I can say Jara. You see how crazy this is? So it doesn't have a schema, right? It doesn't have a schema. It's just whatever you put here, that's what's gonna be fetched, right? So in the other one, it has a very strict schema where you have age, first name, last name, product, and that's it. There's no way to customize this. There's no way to make this flexible in RDS, in a relational database. But with this guy, you can create an item with different attributes. It doesn't matter.
So it's basically using tagging as a form of database information. You can keep adding tags to the line, and one row could have the information and the other ones do not. That's a pretty clever way of doing this.
Yeah. So you can have items here, and it's only one table. You can have different items in one table. There's no relation between one table and the other. Okay, so it's better to have everything together here. Okay, for example, in the College Board for all the SAT users and proctors and professors and administrators and everybody was in the same table, and they don't have the same attributes, right? They don't have the same attributes. A student may have a specific, but a student doesn't have any credentials, right? The credentials are entered by they have credentials, but they don't have to use it. They have different roles. I could get another table, right? And I can say my second, they have to have a unique name. Right? And then I can say ID, right? And then I can have a sort key. And let's say that creation date. Right? And then here, I can use these guys here. Add index for secondary index. I can have the capacity. If it is on demand, provision. The estimated cost per month is going to be $2.99 per month. Okay. So I don't think the Dynamodb is included in the free tier. That's why it says a cost here. Or we're not using the settings, the default settings. That's the thing. If you're not using the default settings, then you are not being charged for that. I think you might be. Okay. So if I come here, let's say AWS free tier limits. Let me see something here. If I says DynamoDB, DynamoDB.
can filter by feature on the left-hand side.
Maybe you could just Google, is Dynamo DB included in the free tier of AWS?
Yeah, I wanted to see it. I wanted to see it from here. This is not storage. This is database. Okay. Dynamodb 25 gigabytes, always free.
Okay.
Fast and flexible NoSQL database with seamless scalability. Okay, so I can have this database here. Okay, I want to keep the settings. Okay, and then I create this table. I have my second table. Okay. So when I create an item, you see, I can have here ID duty X001, and then I can have here 2020, and then the month, let's say it is 5, then today is 15. So I'm gonna have this, and then I can sort this table. I can find it using either the primary key or the sort key. I can use either ones. All right, either one to just query the database. You see, I can use either the partition key or the sort key. All right. So the creation table, say I want to find the one that is 515, okay, and then search. Our string value is the key. There's only one now right now, right? But just in case we have another one, let's say that I want to create another one. Let's say Orlando 001, and then say 2020, and then here 0514. Okay, 05. Okay.
But you have to search including the two, including the primary and the sort key, both of them.
Yes, for sorting, yes. So I can do it now, and then we'll find this one. Okay.
So you cannot search only by creation date, as mentioned before.
No, doesn't let you. If I do this, you see? Okay. But then you can customize your query using a third party like GraphQL. You know, maybe you want to find something with the name.
Because because in this case, the table, when you created the table, both were keys that were defined as such. So you define primary and sort, sorry, partition and sort key. So if you had defined only one partition key and added different tags, you could have searched by any tag, right?
Right. Let me see. I have this. You see, I can have the same ID, different creation dates. All right. In the relational database, the ID is unique. Okay, the ID is unique because using the ID as a primary key is how you usually find something. But here, there's no strict schema. It's very flexible. So if I want to find Dbs 001, and then I say 16 here. Right. And let's say that I want to find ascending, same thing. Just in case you have two Dbs 001 and 2, let's say that the same customer placed two orders the same day, 2 orders the same day. Okay. Or maybe the creation time can be entered by a system. It's going to have some seconds here, the time as well, like a timestamp. This is only the date, but you may have a timestamp that has the day, the month, the year, and also the time. Okay. So this is.
Can you display the entire table again?
I'm sorry?
Can you display the entire table content again?
Which one? What table?
The one by Dynamo Db second table.
Okay, let me move this guy here. That's it. Okay.
You have to delete the string, maybe?
Yeah, because you're only asking for that string, so you don't take that string off.
What happened? Yeah, where is the string equal?
Yeah.
Okay, that's what makes that this database a little. Okay, this is the second one, the first one. Okay, the second one, I need to delete this guy. Okay, there you go. Okay. That's the database. That's the table. Maria?
Oh, sorry, I'm talking to I'm muted. Apologize. Okay, I see.
Okay.
So with the same ID, you can have.
Yeah. The ID doesn't have to be unique.
Yeah.
Yeah. It's a different concept. It blows your mind away when you see it for the first time.
Yeah, I'm trying to equate this to, you know, it feels like it's an Excel with tags, kind of like a combination of multiple ways of outside of a regular schema database.
Yes. So it runs exclusively on solid state drives. It doesn't have HHD like EC2 instances or Dynamo Db. RDS supports document and key value store models. So when you create an item, it has a key and a value. Okay, that's JSON. Whenever you hear a database that uses JSON format, that is Dynamo DB. Don't forget that. Okay.
Say that again to write it down.
Yeah, very important point. Whenever they ask you in the exam that the company is looking for a database that is created in JSON format, that is DynamoDB. Okay, very important. It's a key value database, key value. Okay. The global tables feature replicates your DynamoDB tables automatically across your choice of AWS region. I think it's somewhere here. Let me see. Tables. Tables. Global tables, right here. Global tables. Okay. You can add a region. You can add a region. Of course, this is a free tier. Doesn't have that. Yes, go ahead.
So, sorry for my ignorance. In terms of JSON, give me one 30-second definition of what is JSON. So, I mean, for those that know Java, fantastic,
JSON,
but I have no fucking idea.
JSON is, let me see here. JSON is, let me see what I have here. JSON is
it a programming language or something?
No, JSON is a JavaScript object notation. Okay. For example, if I do this, let's say that, what is this? Yeah.
For JavaScript,
if I say name, Dunieski, last name, Otano, age, 15. Now, if I say format JSON, this doesn't work, okay? But JSON is like this, okay? JSON is like this. Okay. And numbers are not put in quotations. Okay, so this is JSON, right? I think I showed to you guys, I think it was in the afternoon class, the CloudFormation that was in YAML and JSON. Okay, JSON is JavaScript object notation, right?
Mm-hmm.
That uses key value pairs, right? Key value. Strings are a string, which is a group of characters, are between quotation marks. Numbers are not. Okay. And basically, DynamoDB, what DynamoDB uses is a key value pair. Key, the key is right here, and the value is down here. Okay. When you create a new item, you have the key, and then you have the value. Then you create another item, another attribute, I'm sorry, and then you have another key, and then you have another value. All right, and then you have another key, which is a name, a number, and then you have another value. You see, it's key values, and then you have another maybe Boolean. I use a young.
And that is like a kind of the field name and the content of the field, for other, say, databases or documents. Okay.
Yeah, and when you say Boolean, is true or false. Okay, that's a data type in programming, and also in databases. When you say Boolean, that means true or false. Okay, you have several types. These are the types that you have, types, because the value has to match a type. If it is just a word, it's gonna be a string. If it is a number, it's gonna be a number. If it is a list of things, not only one, a list, and then you're gonna have
an array.
Yeah, like an array. Yeah.
Mm-hmm.
And then if it's Boolean, then you have true or false.
What is map?
Map is like a map is like an array as well, but then you map it the way you want. You map it the way you want. That's even for programming. You want to, for example, you have this order here, ID, name, age. When you map it, you can say young first, and then name, and then age. You just map it the way you want. In this case of DynamoDB, I'm not very quite clear how they use map, but map has to do with that. A map is like a set. It's a set of values, but it's specific with a specific index in programming. Here we have to, let me say here. Okay, DynamoDB. Map type. Okay. Let's see if it's here. Let me see if I can find it here. Document type can represent a complex structure with nested attributes, such as would find in a JSON document. The document types are list and map. I know what it is. Okay, let's say, for example, that, let me see if I get it right. So if I say here, let's say Dunieski 01, and then I have here, let's say append map. Oh, yes. So it's like you have here, let's say products.
Mm-hmm.
And then you can say here, products. And then you can have here, let's say string, name, bicycle. No, bicycle.
Mhm. I have the same problem.
And then another one, let's say, you see, a product has one, right? Let's say you want to
So
have
it's a list. Oh,
yeah, it's a list of objects.
of objects.
Yeah, so another one here. Let's say that you want another one. There's a number. It's a salary. Let's say 3489. Okay. And then you have another one here. Let's say that you want to append. Let's say no, not here. Here, you want to append wife's name. You see, wife's name, and the wife's name is Yara. You see, they all belong to the same object, the same attribute, but they have an object inside with different. It's like an item of an item, like an attribute of an attribute.
Mm-hmm.
You see, so you have this inside. You have several things. It's like a nested attribute. So I can just remove this one.
Can
And
you
then-
save it and see what it does?
You see, right here. Okay. So we check that. You
Yeah.
have it, three products here. So whenever you fetch this, you're gonna bring these guys. So usually they are fetched like this: products, that name, something like that. That name with capital letter. And then
Can you go back to the other window? Can you click
when
on
you
save?
do products, that name, you're gonna get
Uh-huh.
bicycle. Okay, so I can save it, and then it's here, and you can
Now
get it.
now it's using object oriented
Jason.
type.
Yeah, Jason. That's Jason.
Wow, I
Jason,
like this.
Yeah, it's beautiful. But it's costly. But heavy duty companies will use this. So you have a map here.
So if you click on name, can you close this window that you have open? The one that says cancel save, can you cancel? I want to see some. Can you click there? What is it?
Where there's a
Where it
cancel.
says name, I'm sorry, where it says name?
Here?
Name in quotations, right there, click.
No, you have to click on the pencil.
Ah, okay. Oh, I see.
Just in case you want to edit it or something, you want to add another one, you want to add another field. In this case, we have computer, Mac, MacBook Pro.
Okay, so how do I apply now? Let's say that I have this product and I want to apply it to other IDs in this table.
No. You cannot do that.
You
There's no
can't?
relationship. No, there's no relationship between them. This is not a non-relational database.
I know, but let's say that I do want to have a product in 02 or Orlando 001. Does it allow you to copy that?
Copy? I don't think so. Copy? No, I don't think.
So you have to recreate. You have to recreate it again.
Yeah. But you can create a table from your API. It's an API call from your application. You can create items. You can create items using a Lambda function too. You don't have to come here to the table and create items here only. You can do it from a Lambda function. Okay.
So you can do it programmatically.
Of course.
Which
Yes, you can do it programmatically. Okay, Oscar.
Yeah.
So you see here is just a name and this like a key. If I just click here and put text, it gives me is JSON. You see, that's what behind it. That's what behind it.
So that's JSON.
Yeah, you see.
Mm-hmm.
You see, that's JSON. Now, if I do this one, right, and I bring this text, you see, and if I do Dynamo Db test, you see, products, and inside every product, there's one little object. Okay, It's just the list of objects.
So Professor, it's like a programming language?
It's a notation.
A notation.
It's an object notation. Okay.
Object notation.
It's not a programming language. Okay. It's just notation. It's just key values,
Okay.
key value pairs.
Okay.
So idea for mobile web gaming, advertising technology, and IoT applications are accessible via the console, CLI, and simple API calls. Okay, so you can create a Dynamo table from the CLI. You can create a Dynamo table in the console, or you can just do it from a simple API call. Okay. A Lambda function, for example. DynamoDB is a fully managed NoSQL database service, consistent, single-digit millisecond latency. This, don't forget about this, okay? It's a single-digit millisecond latency. It's super, super fast. Just remember this. Put it on your hard drive, on your mental, on your mind hard drive, okay? This is key, okay? NoSQL is a keyword here. Single-digit millisecond keyword. JSON format is a keyword, okay? Don't forget that. Items is a keyword, okay? Attributes, key items, simple word. The only table that has items in AWS is DynamoDB. Okay, the other ones have rows and columns. They're named like that. This is items. Okay, in other tables you say I'm gonna create a record. Okay, in this table you're gonna create an item. Okay, no table size or throughput limits. There's no limit. And global tables eliminate the difficulty of replicating data between regions and resolving conflicts, update conflicts. So here, if you want to just have a global table, you can enable a region. Let's say that you want to have another table in, let's say, right now this one is in North Virginia. If you take a look at this, North Virginia. So I can have one in Paris. The region is ready, clear replica to proceed. So I start creating a replica in Paris. Internet server error 500, you know, error code in terms of this, because I have probably a free tier account, so it doesn't have that capability. It's giving me 500 status code. That means that there's a server problem. Okay, let me choose another region. Let's see what happens. Let me choose one that is closest to me. Let's say Ohio. You're creating a 2011-21 version global table. If you need to create a version, global table, okay, it's created. Same thing. All right. So maybe because I have a free tier account. Okay. Free tier is very limited, very. Okay. So I already gave you a demo on DynamoDB. So now we're gonna talk about Redshift. So Redshift, don't forget, whenever you hear the word.
Wait. Just a second, Junaski. Don't you have a slide here about, you know, what is free or not on DynamoDB, as you've had on all the other things?
Okay, remember that I put it here. DynamoDB is 25 gigabytes of storage, 25 provision write capacity units, 25 provision read capacity units, enough to handle up to 200 million requests per month. This is what's free. Okay.
Okay, so everything regarding distributing that into regions, as you just try to do, etc., it's not free. It will have it with a cost. Okay.
In this case, DynamoDB, right here, overview, we are using 5 provision read capacity units and 5 provision write capacity units. In the free tier, we have up to 25. Okay, so it's free. don't forget that this is only for, well, actually, this is always free. Okay. This is always free, but RDS is only 12 months free. So this page, I think I posted, is one of the, what was one of the materials that I posted a few classes ago, and I don't remember, but I posted the limits. Okay.
Yeah,
So
if you're so kind, please repost it if you don't mind.
this one.
Thank you so much. Sorry.
So I can put it here.
Because indeed there was a question somewhere. I can't remember if it was on the test or on the one of the tests. I think it was regarding limits. Indeed, I had to go online to search it, honestly speaking. So,
Omaro, did you find the Nearpod presentation? Omaro? Is Omaro here?
Yeah, yes, I got it.
Okay.
Thank you very much.
Yeah, every single presentation for this class, every single presentation is on Nearpod, and it's posted every single class on Google Classroom. Okay, Amazon Redshift is a warehouse. Okay, it's a warehouse. So the keyword for this guy is warehouse. Okay. Remember, the exam is mostly about keywords, okay? It's a fully managed data warehouse that makes it simple and cost efficient to analyze all your data using standard SQL. So it uses standard SQL and your existing business intelligence. So this is mostly for BI, okay? So let's take a look at that. So introduction to Amazon Redshift. So we have a complex SQL query here, SQL query here, SQL here. So all these are information is fetched using SQL. But it's, you know, if you want to have business intelligence analytics, this is the guy. Okay, that's why many companies are using Amazon Redshift, because it's fast and powerful. Okay. And above all, is fully managed. Oh my God, one moment. Simple. It's not difficult to use, and it's very cost effective. Okay. You can run very complex analytic queries. You know, and it doesn't matter how big it is. You can have petabytes structured data here, and you can have sophisticated optimized queries, and everything is going to be in columns, is columnar and high performance. Okay, so we have virtual cores here. So this is by cores. Okay, it has an architecture that has parallel processing, so you can process several queries at the same time in parallel processing. And it has a virtual core, RAM, and local disk. Okay, that's the computer node. So the leader node that you have here, what it does is manages communications with client programs and all communications with computer nodes. It parses and develops execution plans to carry out database operations, in particular, the series of steps necessary to obtain results for complex queries. The leader node compiles code for individual elements of the execution plan and assigns the code to individual compute nodes. The compute nodes executes the compiled code and send intermediate results back to the leader node for final aggregation. So as you can see, it's a little complex the way that Amazon Redshift works, but for this particular class, you don't need to know how it works. What you need to know for the exam is that Amazon Redshift is a data warehouse for business intelligence analytics. Okay, that's what you need to know. And it works in conjunction with Dynamo Db and Amazon S3. Okay, So Amazon S3 is for storage and DynamoDB is for databases. Okay. So it has it's automates and scales automatically because it's fully managed. It's managed, monitor and scale. All of this can be done with Redshift. What you do when you have a Redshift, you create a Redshift cluster. It's quite simple to automate most of the common administrative tasks to manage, monitor, and scale your Amazon Redshift cluster, freeing you up to focus on data and business. Okay, so you can work on your business and forget about all of this, overheads here with Amazon Redshift. So we have Amazon Redshift is already compatible with tools you already know and use. Redshift supports standard SQL and provides high performance JDBC, Java development. Java DBC is Java database connectivity, and ODB is Oracle database connectors. So I can connect to all this Java program or Oracle databases, which allows you to use the SQL clients and BI tools of your choice. Okay. So some use cases when you use Amazon Redshift, for example, enterprise data warehouses, EDW, migrate at a pace that customers are comfortable with, experiment with a large upfront cost or commitment. There's an upfront fee, but it's not large, and there's no commitment. And respond faster to business needs. Okay, big data. Okay, just in case you want to get in the big data world, Redshift is one of the services that is used for big data. Also, there's another one. This guy, I don't know what happened with RDS. Is spinning there forever. I don't know why. So this is another one that is used for big data, very popular. Amazon Glue. Okay. That is used for, by the way, I was using it here as well. You can use Amazon Glue in conjunction with another service is Athena. Athena is an interactive SQL service. It's fast, cost-efficient, interactive query service that makes it easy to analyze petabytes of data in S3 with no data warehouses or clusters to manage. Okay, so this is something that is apart from Redshift, that is used for creating a database here and then get the data from an S3 as well, and just the results will be shown here. Okay, just in case you want to just get information from your per S3 bucket, any columnar rows here, then you can query your S3 bucket and get the information from here. Okay. Athena, don't forget that. You may see it in the exam. It's not part of this class, but you will see it in the exam as one of the choices, right, in your answers. Amazon Redshift, it's for SQL clients and business intelligence BI tools. All right, so big data, low price point for small customers, managed service for ease of deployment and maintenance, and focus more on data and less on database management. Okay, big data, it's all about data. That's the concept. That's the logo, the motto. It's all about data. It's all about the data. Okay. If you come here to AWS, Amazon, and then certification. Okay. So we have this guy here. there's one specialty that is big data. Where is it? What? Oh, they changed it to data analytics. They changed the name. This used to be big data. They changed the name. Oh, nice. Okay, this is a specialty. You see the price? Mm-hmm. That's in this guy with this certification. Then you're gonna use Redshift, Amazon Glue, AWS Glue, Athena, all those guys that have to do with big data. Look at this, what they ask for that as a requirement. Okay. I don't believe in any of this. Okay. I can, and you can too. I can learn big data in a month, over a month, and then pass this exam. It's just a matter of dedicating time to it. Okay.
They don't put in there really what you need, which is a good math background.
Where?
They don't have it there. They don't have it.
No, because it's I mean,
it is assuming that you have a good math background.
Well, in the developer, when you see the developer certification, everybody thinks that they assume that you have developed the coding experience. No, you don't need that. All right. This certification is just, all of them is just dedicating the time, study, take courses like Udemy courses, and that's it. You don't need to have any 5 experience or anything. Like I said, the very first day of class, I got all these guys with 0 experience in that particular section. Okay. When I got these guys, I have more experience now. I have over a year, 2 years with that. But when I did all these guys, I didn't have any experience. Okay. Especially this one. Okay. But they asked for 2 or more years of a hands-on experience. If you go by this, I mean, I know people who have never worked as with machine learning, and they have passed this as a certification. I know a guy on LinkedIn that has all of them. It's impossible that you can be an expert in all of them. It's impossible. You can be an expert in 1 or 2, but you cannot be an expert in the 10 of them, right? 11 of them. That's impossible. Right? In my profile on LinkedIn, there's some people that have there asking me, hey, how can you possibly know everything? Some people don't believe that, okay? But whatever you see in my LinkedIn account is the truth. I've worked with all that, but I'm not an expert in everything, right? I can be an expert in some stuff, but it's impossible. I mean, I don't have time for that, right?
You have to tell them that you're a hybrid professional.
Yeah. So, scale the software as a service. Amazon Redshift, it's a software as a service. Scale the data warehouse capacity as demand grows. It's highly scalable. Add analytic functionality to applications, reduce hardware and software costs by order of magnitude. So you can accomplish all this with Amazon Redshift. Okay, this is the the core of what we saw before. It's a fast, fully managed data warehouse service. Okay, data warehouse, easily scaled with no downtime, 0 downtime, columnar storage and parallel processing architectures, automatically and continuously monitors clusters, and encryption is built in. So you don't have to worry about encryption. It's already encrypted for you. Everything that you do with Amazon Redshift is encrypted because you're working with big data. It's a lot of data. It have to be encrypted. Okay. Amazon Aurora. You don't have any questions, guys? No questions?
No.
Okay. It's nothing fancy, nothing difficult. It's just, you know, I know it's a lot of information.
Yep.
I felt overwhelmed before taking this exam, but you have to take it one at a time, you know, one day at a time. And like I said before, and I always say that, don't leave everything for the last minute. It's a lot of information, a lot.
Mhm.
And the more you're advanced in AWS, you have more information. Okay, much more information. Remember what I told you about the icon for RDS is the same for Aurora. I still don't see why. Maybe because it is the only one that belongs to AWS. I don't know. Never asked anyone about it. I don't care. But yeah, just speculating. You know? Amazon Aurora Service benefits is fast and available. It's managed by AWS. You pay as you go. Compatible, single. Uses SQL. Okay, it uses SQL. So with Amazon Aurora, you can get SQL. The information using SQL. It's very simple to use, right? What you have to do is just when you come here, when you have a database, right? You can create a database and choose Aurora, right? Database location is regional. You can have it global if you want to, right? And you can have one writer, multiple readers. You can have multiple writers, serviceless, because Aurora has a portion that is serviceless. This one it has a server, right? But you can go serviceless. And you know that's called a customer, of course. And the more managed the service is, the more you will have to pay. Okay?
Professor, you know, I still can't wrap my head around that serverless because I'm still thinking in terms of there being servers somewhere.
Okay, what you have to do understand is that when you say serviceless, you, not AWS, you don't have to work with any servers.
Okay.
There's no server behind that. Okay, AWS has its own servers because remember, the global architecture is its regions, right? Availability zones, data centers, and the data centers, they have servers, like 50,000 to 80,000 servers. Everything is managed by AWS, right? But when you have a server, you have to install the patches, all that, right? In this case, you don't have to do any of that.
Okay, so serverless means you don't have to deal with the servers.
You
AWS does it.
That's right. You don't have to manage. There's no server involved.
Okay.
For me.
Okay, for the user. Okay.
Yeah. So all these guys, you do the same thing. You create the username, the password for the master. There you have more options here because Aurora is not free. Aurora is not free. You have to pay for Aurora. And this is a heavy duty database. Heavy duty. You create an Aurora replica. Okay. Reader node in different SEs. Don't create Aurora connectivity, private. You can put it inside a VPC, password, everything here. Right. Almost the same as the other one, but don't forget that this one is not free. Okay. It doesn't even give you a choice to create, select a free tier or anything. It's just paid. You have to pay for it. Okay. Okay, what happens with Aurora, that's why it makes it more expensive, is that immediately when you create an Aurora database, right? What happens is automatically it creates 6 copies for you. 6 copies. And 2 in 3 availability zones, 2 per availability zone. That's something that happens automatically, right? That's one of the reasons why you would choose Aurora over RDS, for example, right? If you want to be highly available right off the bat, Aurora is the guy, right? Because it gives you that. Okay. Now, this is highly available, right? Storing 6 copies of your data across 3 availability zones, right? With continuous backups to Amazon S3, continuous backups to Amazon S3, right? Now, it can have up to 15 read replicas, right? You can use that to ensure that your data is never lost, okay? So, keywords, Amazon Aurora, highly available, 6 copies in 3 availability zones. These are my exam tips. 6 copies, 2 in each availability zone, 3 availability zones, up to 15 copies of replicas of your data. Okay, and now it will not be lost, right? And it's constantly backing up your data to Amazon S3. Okay. This is built also for instant crash recovery. In the event that your primary database becomes unhealthy, it will recover instantly. Yes, go ahead.
Yeah, so bear with me a second. So, and being kind and sincere, what is the purpose of discussing those terms that, 2, 15, 3x2 or whatever? If when we, I mean, if there's out there, when you just need, a limit, just go check, what is the limit for Aurora? Boom, you have it. So, I mean, it is, and the point is, I mean, I'd rather understand the concepts than knowing the details of the limits and, all those things, because, I mean, I don't really,
okay,
see what is the point of knowing, again, that,
okay,
5 or 2 or 3 or whatever, it's important. I mean, I don't get it.
Are you gonna tell AWS to change the exam?
Well, no, I mean, but that comes to the point in which we were saying the other day, if we're doing is trying to pass the exam or not. But
this exams is more theory than anything else, right? So you have to know why Amazon Aurora is the preference of many companies. Why people would choose Amazon Aurora over RDS is exactly because what I'm telling you. It has automatically high availability in 3 availability zones, creating 2 copies for availability zone. That's what makes it so preferable in many instances, right? And also you can have up to 15 replicas of this database. Okay. Now this is when you want to compare. For example, you want to talk to a business owner about. You're gonna give suggestions to a business owner, and you're gonna say, well, you may use RDS, but what if I tell you that Aurora is a better choice because of this and this and this and this? Okay, and probably the guy says, oh, good numbers, I like it, let's go with Aurora. Now the exam is going to test you on this. It's going to test you on this. It's basically the exam is basically about theory, numbers, specific statistics, features of a service. It's mostly about that. Both AWS Cloud Practitioner and Microsoft Azure Fundamentals, which is the first one for Microsoft Azure, because I took both exams. This is just about numbers and description of services, more than anything. It's not services applied, like applied knowledge. This is knowledge only, right? It's not applied knowledge. But you have to know why Amazon Aurora is much more excellent than RDS. It's more costly, but it's much more excellent because of this high availability features that it has. And for RDS, you have to back up. For Amazon Aurora, you don't have to back up. It's constantly backing up for you. So this is, I mean,
that's okay. That's okay. I was gonna ask you, and that you're basically trying to going through something that I was gonna ask you as well. That is, will we have, when we finish the database section, a sort of exactly what you're mentioning, a comparison between, when to use one, 2, or the other, or it's just based upon the comments that you've been throwing, in this session?
No, in the exam, you're not gonna. I mean, I don't think there's gonna be any questions about comparison.
Well, no, but if I have somewhere where it tells me, as I think there's been in the past as well, you know, somewhere where we've been comparing when to use, you know, this certain scenario, when to use this certain scenario, and there were some, you know, pros and cons there, right?
Yeah.
I was expecting the same in databases, you know, otherwise it is a lot of, you know, small things that we have to take from different slides, but that's okay. That's okay. We'll do it.
Yeah, you
That's
may
okay.
have a question in an interview that they ask you, what would you choose? What
No worries.
Will you choose an RDS or Amazon Dynamo DB or Amazon Aurora? When can I choose one? I mean, when do I use one? You have to know the characteristics of each one so that you can give the guy, I would prefer this one because of this.
So,
but if you want to go for speed, maybe you will consider Dynamo DB. If you want to go for NoSQL, Dynamo DB is the guy. Now, if you want to go for SQL, then we have to compare Amazon Aurora and RDS. Where actually RDS it's part of Aurora is part of the RDS, but Aurora is its own proprietary thing. Okay, it's
so
like
giving us context, Professor.
It's like a special. Huh? It depends.
I said you're giving us context.
Yeah. Aurora, it's a special guy. You know, you have to use RDS to use Aurora. Okay, but we can compare Aurora with RDS. That's a little conflictive. How can you compare something that is inside something? But still, we can compare that because you can have RDS with Postgres, right? And that's going to be a different ballgame. It's going to be less available than Aurora. Okay. Even though Aurora is inside RDS, because when you create an Amazon Aurora database, you have to choose RDS service. You have to choose it, right? But you should know that you should know each service's use case so that you can compare. When people ask you, you can answer, and people will know, oh, this guy knows what he's telling, what he's saying, because that will be that could be a question in an interview, very easily. Why would I choose RDS over DynamoDB? Tell me. Okay, they can ask a question. They have never asked me a question like that, but they have asked me similar questions with other services. So resilient design, redo log files. Unlike other databases, after a database crash, Amazon Aurora does not need to replay the redo log from the last database checkpoint. Instead, it performs this on every read operation, which is good. Databases, you have to go to there is something, you go back to a checkpoint in time where you can retrieve the information from that point. But with Aurora, you don't need to do that, because in every single write, that happens. That's even much better. I mean, this database is very resilient, very, very resilient. Okay. So this reduces the restart time after a database crash to less than 60 seconds in most cases. In less than a minute, you can have the database up and running again. Okay. So this is very, very, very effective. So database, it's Amazon Aurora is high performing and scalable. It's highly available and durable. Multiple levels of security. Compatible with MySQL and Postgres. So I can tell you that Amazon Aurora is 5 times faster than MySQL and 3 times faster than Postgres. That's something that you can remember as well. It's 5 times faster than MySQL and 3 times faster than Postgres. Okay. Running on the same hardware. Okay, so it's super fast. Okay. So the performance is on par with commercial databases at 1/10 of the cost. So it's not, let me tell you something, even though it's expensive, you can get to a point, if you have a big company, where you can save a lot of money with Aurora. It just depends on your specific situation. Okay. So in the lab, what's going to happen? Let me show you in Vocarion. I want to show you with the slides, just in case something is not exactly accurate. So Cloud Foundations, assignments. So today's lab is going to be building a server. Okay, that's number 5. Building a database server. Okay. So, but I can show you if I'm logged in as a student, not as me. Okay. So here. So in this case, this is the initial infrastructure that you're going to start the lab with, right? So you have a region, and then you have the 2 availability zone, A and B. You have an internet gateway, right? And then you have access to these public subnets, right? With 24. Remember, 24 is 256 IP addresses, but Amazon takes one, is type 5, is 351. 251 IP addresses per subnet, right? Per subnet here. And then you have a NAT gateway here, a NAT gateway, okay, which allows communication to the internet from the private subnets. We have a web server here that has a security group, right? And then you have 2 private subnets here. And question for you guys, what makes a private subnet private?
Access to gateway.
Access to what?
To the internet gateway.
That's right. Okay. And access, what do you mean by access?
That is not connected to the internet gateway.
Okay.
No.
Okay, good.
Quick one, before and sorry to because I got lost a bit the other day on the, and you know, there was a fantastic guy on the chat on the class that wanted to give me a hand, but you know, we didn't have time at the end. On IPs, what is the relationship between the 24 and 25 and 256? I'm sorry for this stupid question to you.
So
but,
whenever you put /24, it means that you're allocating here 256 IP addresses.
Yeah, that I know because you tell me. But you know, what is the mathematical relationship between 24 and 25 and 256? Is it because it's not a square, it's not power? What is that?
No. It's just a number. You have to. You practically have to memorize that.
Oh, okay. Because I was getting completely.
No,
you know, I was trying to figure out why 256 is 24. And okay, got it. Okay.
You have
so
to
24
know,
means 256.
You have to know that you're going to be able to use 256 of these 4 octets. You're going to have 3 octets locked and 1 only be available. That's 256. Every single has 256.
Yeah.
So here you're going to have 256, but Amazon automatically takes 5. So you're going to have 251 per subnet. Okay.
Oh, is it probably because 24 means 3 octets times, so 3 times 8 means 24, and that's a 24 there. So 256, you know,
Yeah.
each.
So this one's that 3 octets are unlocked.
Okay, fuck. Okay.
Okay.
Now I understood
it. Yeah, but I mean, don't go by that, because if you have 28, how can you do that? You know, it's this goes from 32 down. Okay, 32 down. I think it's the last one is 8. I think 32 is only 1. 29 is 32 is only 1. 31 is 2. 30 is 4. It multiplies by 2. 29 is 8. 28 is 16. 27 is 32. It goes that way, going down.
Okay, got it.
You get to 24, it's going to be 256. Right?
Okay.
And then 23 is going to be 412, and then 22 is going to be 1028. You know, but 1024. I'm sorry, and then it's going to be 1056. You know,
the power.
The lower you go, the higher the amount of IP addresses.
Okay.
So we're gonna have this is your infrastructure at the end of the lab. Okay. So you're gonna basically what you're gonna do is just put the two databases here. You're gonna put the master and then the secondary, right? So you're gonna do exactly what you always do, start the lab, and then at AWS, you're gonna come here to the services and select security groups. You're gonna create the security group before, because don't forget that a database also has a security group. Don't forget that. Okay. So then you create the inbound rules and you know.
Professor, does the exam doesn't have labs, right?
No.
Okay.
No, it's just only theory. Okay, so you're gonna allow port 3306, which is MySQL Aurora access. Then you're gonna create the subnet group. Okay, and all that, and the subnet group. You know how you create a subnet. You know, I explained that to you the other day when we were in the VPC section. Now we're gonna go to Amazon RDS, and then you're gonna select multi-AZ, right? But as this is an Amazon account, you don't have to worry about any charges. Remember, when you have multiple AZ in your own account, you're gonna be charged, right? But in this case, you're not gonna be charged. It's Amazon platform created for you, right? So you create a database, then you're gonna select Amazon SQS. You're gonna switch to the new database creation flow, select MySQL, right? And do exactly the same thing, you know. And just put here, general purpose, allocation storage 20, and then the lab VPC, that's gonna be there created for you already. Initial database name lab, enable automatic backups. You're gonna uncheck it. You're gonna uncheck that, you don't need that, right? So click create database, the database will now be launched, right? Click lab database, yeah, and then you will now need to wait approximately 4 minutes for the database to be available. While you're waiting, you might want to review the Amazon RDS frequently asked questions. You can click on this and wait until info changes to modifying and or available. Okay. Scroll down to the connectivity and security section and copy the endpoint. Remember what I did when I used dbeaver, that I copied the endpoint, paste the endpoint value into a text editor. You will use it later in the lab. Now interact with the database, copy the web server IP details. You know, this is very, you know, where and clearly explained here. So it's not gonna be a difficult lab. You have done more difficult ones than this one. Okay. So basically, what you're doing, what you guys doing here, it's just having this product here, adding these two databases here, the master one and the standby one. Okay. So do you guys have any questions? I'm gonna stop the live streaming now.